Okay, so you should have tried this yesterday. You're watching this answer key video to kind of help walk you through what the answers are instead of just reading the answer key. So for the first part here, it's a review. For questions 1 and 2, you're writing true or false. So T or F. So the first one says that ray, and remember this stands for ray, AB names a ray with endpoints A and B. And so this would be wrong because a ray, right? A ray only has one endpoint. So it's not naming something with two distinct endpoints. So this would be false. Second is you name a ray by its endpoint and one other point. And so that is true. It has one endpoint. And then you have to pick another point on that ray to be able to name it. So this is true. So a little vocabulary here. We started talking yesterday about, or in the notes section of this, an angle. And an angle is just formed by two rays with the same endpoint. So an angle is basically two rays and they have the same endpoint. So if I wanted to sketch it, I could show you that by doing one ray this way, right? And then I could draw another ray starting with that same endpoint going this way. And that technically is an angle I just formed. Two just separate rays, but they make the same or form one single angle. So we are going to, for 3 and 4 now, we worked on this in the notes as well, name the rays that form each angle. So we want to pull apart basically the two rays here. So the first ray starts with endpoint B and it extends, should try to make this a little neater, and it extends through point A. So the first way we can name this is BA, and we're going to put a ray symbol above it. The second ray that makes up this still starts with that same endpoint, but goes through now point C. So that would be ray BC with the ray symbol above it. Notice that the key thing here is that they have the same endpoint. They both have a B as the endpoint. Okay, so then when we look at the second one, same concept here. The first one that we're looking at is ray A, B. So now A is my endpoint. So A, B with the ray symbol above it. And then we have AC. So it's AC with the ray symbol above it. And again, big thing here is that they share the same endpoint. So they both have A and A here. So they're same endpoint. Okay, so again, below here we have the key concept box, which just says that an angle is formed by two rays, which we just kind of pulled them apart to dissect that have the same endpoint. The rays are the sides of the angle, and when they touch in the center here, right here, so this is called your vertex. So there's 3 ways to name an angle. The first way is by its vertex, which is that point. So in this case, this would be A. So we could name it, if I look at the diagram, angle A. That would be one way. Another way is a point on each ray and the vertex. So you would go sequentially and you would start with, let's say, BAC. So it would be angle BAC. That would work. And the last way is with the number that's in the center. So that would be angle 1. So 3 different ways to name the same angle. You should know how to do all 3 of them. Okay, so we're going to basically use this little chart here to kind of pull apart this diagram. So it says, name each part of this angle. So the vertex. So the vertex, like we basically just kind of did this. The vertex is this point here. This is my vertex. So that's A. Okay, 2 points that are not the vertex. So the 2 points that are not my vertex are going to be that B. Whoop. Change the color so you can see B and C. So you would just write B and C. And then the sides. So the sides, obviously, they are rays. So you want to use the vertex as your start point for both of them. So when we do those, we want to start with, we could do ray A, B, and we have a C with the ray symbol. Okay, so those are your sides of your angles. So basically, we just took one angle and we dissected it and kind of pulled it all apart. Now what we're going to do is we're going to name it, which we actually did in this little section right here. So we're just going to reiterate it. So by its vertex, we would call this angle A. Okay, another way is you could use the angle symbol with the line through it and say angle A. Second way to do this is by a point on each side and the vertex. So we could say this is angle B, A, C. A has to be in the center, or we could say angle, and we could reverse and go the other way, C, A, B. And then the final way to name this is by the number that's in the center there. So this could just be angle 1. Okay, so now we're using and changing the diagram up. It says, what are two other names for angle KML? So we're talking right here about this, KML. And the best way to do that is tracing the letters as they're saying them. So in order to come up with those names, we are basically going to break this apart. So it says, cross out the ray that is not a ray of this given angle. So when we look here, we have two rays. Both should have an endpoint of M because that's the endpoint or vertex in this angle that they're referring to. So these all have an endpoint of M, so that doesn't really help us. So the first one we're going to pull out here is the one side. We have MK, right? So this one is good. Then if we do the other side of this, we have ML. So that's this one. So the only one that is not on that angle is MJ. MJ kind of goes this way. It strays off the other way. So then it says circle all the possible names of angle KML. So KML again. So if we want to name this, we could name it by its number. So that would be 2. So 2 would work. Okay, and then the other way what we could do is we could reverse the letters. So they're calling it KML. We could jump and make it LMK, which would be this one here. Okay, just take note, and this was in the actual notes section, you cannot call this by the single vertex letter because it's actually comprised of two separate angles. So you have to either use the 3 letters or the number way. Okay, and then we go into our types of angles. 4 types of angles we learned. So we are just going to fill this in. So the acute angle goes between 0 and 90. And that's kind of going to be almost like a little bit more of a sandwiched looking, I call it, angle. Okay, then a right angle is equal to 90 degrees. And that's going to have that rigid shape with a little box there to symbolize that it's a square, which means 90. Obtuse would be from 90, between 90 and 180. And that's going to be one that kind of extends open, wider than a 90-degree angle. And then you have a straight, which is basically, think of a straight line, is 180 degrees even. And that's literally going to be a straight line. Okay, so knowing all this information, we can kind of fill in this little diagram here now and answer these questions. So it says in the diagram, measure of angle ABC, so they're talking or referring to this angle here is 70 degrees, which they wrote and filled in for you. Then they're also saying that the measure of angle BFE, so they're referring to this angle here, is 90 degrees, right? Which, again, they labeled for you. They want you to now, looking at other angles in this diagram, describe them as acute, right, obtuse, or straight. So the first one they're asking you about is angle ABC. So ABC is this purple one that I have highlighted, and that's 70 degrees. So if something is 70 degrees, that's between 0 and 90, so it would be acute. CBD is this angle here, CBD, so it's this side. So they didn't give us that, but we do know that this whole line here that this angle forms on here, so this whole one here, this is equal to 180. So if I know that the total length is, or degrees is 180, and they gave me 70, I can subtract to get that missing angle now. So 180 minus the 70 would be 110. So this angle here would be 110. So if I label this 110, an angle that has a degree of 110 is between 90 and 180. So we call that obtuse. Okay, then we bounce down now to CFG. So C is up here, F is here, and then G is here. So if something here is 90 degrees, right, 180 is the total. This would also have to be 90 degrees. So CFG would be 90 degrees, which would be a right angle. And then the last one would be CFH. So C is up here, F, and H. Basically what that is the straight line. So that's basically this, and all straight lines are 180, which we call straight. Okay, so for 16 through 19, you're using the synchronized swimmer diagram, which was in the notes as well. So it should look familiar, and you should kind of know what we did there to help you with this. So this is saying if ABC, so ABC is that angle here, right? So they're telling you that that angle, and I'm going to just erase that because there's marking in there. So they're telling you that that is 49 degrees. So they're giving you that. They're also, if you notice, there's this marking here, that arc, which you see over here on DEF. So that means that this is also 49. And again, I'm kind of getting ahead of myself, but I can put all these markings in because they're there. So this is also 49. So it says angle ABC has, and then it says it has one angle mark, right? I just kind of drew this little arrow here to show that it had that one arc that went through it right here, right? Make it in a different color so you could see it again. So it was right here. And if you notice, the other angle that has that same mark is over here, which is angle DEF. So when two angles have marks that are the same amount of arcs, then they are considered technically equal. So basically then, if angle ABC is 49 degrees, so is angle DEF. So we can then say that this angle here is 49 degrees because they have the same angle marking on them. So now when we move to the last page of this practice, this is that last section of the notes, which is the angle addition postulate, which basically just says that if I have two separate angles that make up or have this interior point, so if I have angle AOB, right, that's that first angle, and I'm comparing it to BOC, right, this angle, if I add them together, this AOB and BOC, which is exactly what this says here, it would make up the entire larger angle. Okay, so this is just saying here, draw me an angle ABT with point L in the interior. So I could sketch angle AB. So my vertex would be that middle point, right? So my vertex would be the B. That has to be the vertex. And then A could be up here. And we could say that T is down here. But they're also saying it has a point L in the interior, which would mean that we'd have to sketch a ray that goes through the middle with point L in it. Okay, and then basically now we've just created two smaller angles within this one. So we've created angle ABL, which is this one here. And then we've created LBT, this angle here. Okay, so basically using this diagram, now we can say that ABL, the teal angle, plus that pink LBT, they make up the entire purple, which was the angle ABT that we started with. And this is basically our addition postulate. Okay, so in this diagram, angle DEF is a straight angle. So they're saying that this angle here, this whole entire thing is a straight angle, which means that it's equal to 180. And they're not even asking you to basically do this work. They're just saying justify what they're saying. So they're saying that the measure of angle DEF is 180. And the reason why is because straight angles equal 180. That's the justification for that. Step 2 is just saying, well, okay, DEF is that entire angle, but I can break that up into 2 separate pieces and say that the measure of this one section of the angle plus the measure of the other, CEF, would equal 180 in total. This is the postulate above, the angle addition postulate. Okay, basically now what they did was they took the expression that was written for DEC and substituted it in, and they did the same thing for CEF. So what they did here, we can just clearly say, is substitution. Okay, and then they went ahead and they solved. So to get from this step to this step, they combined like terms. So they did 11x plus 2x to get 13x, and then they did negative 12 plus 10 to get the negative 2, right? So that's how we're getting those two terms, and that is basically simplifying or combining like terms more specifically. So they simplified, they combined like terms, and then the next step was that they added 2 right? That's what they did here to get the 182. So they added, which is the inverse operation. So they're just going to try to now solve. And then the last thing they did was they divided. So they divide by 13. So instead of actually doing the work, you just had to basically, fill that in. So now it's saying, now that you know that x is 14, substitute them back into these two expressions and find those angles. So let's do the first one. So let's do DEC first. So DEC is 11x minus 12. And we are going to plug in now 14 for x. So it would be 11 times 14 minus 12. And then I would just put that in your calculator and you would get 142. So the measure of angle DEC is 142. Now if we do CEF, we're going to take this expression, so 2x plus 10, and we're still plugging in 14 because the x value didn't change. And when we put that in our calculator, we'll get 38 degrees. So the measure of angle CEF is 38. So this is going to help you for the Google form you're going to do on Friday. Make sure you have it filled in and have it handy for the Google form. If you have any questions, just email me.